In section 8.2, we're looking at the law of cosines, and we're going to use the law of cosines to solve triangles and determine whether or not the law of cosines should be used to solve a triangle. So first, starting up here at topic 1, remember that when we looked in the last section, we developed the law of sines, and the law of sines worked great for a triangle that I knew two angles and a side, where the angle was in between, or if I knew a side between two angles, or if I knew two sides at an angle. And so it did not work in the cases where I had side-side angle where there was no corresponding pair, or where I had side-side-side where there was no angle. I needed to have at least one angle. Now those triangles are solvable, but they're going to require the law of cosines in addition to the law of sines. Okay, so let's develop that law. So if we start here with this oblique triangle, it doesn't need to be oblique, but we're just going to start here for this pattern. And if I look at cosine of C, now C is this full angle here, all the way from the x-axis over to C, but we can find its cosine by its reference angle, the little angle in this right triangle out here. Now, the only thing that we need to keep in mind is that x is going to be a negative value because it's in quadrant 2, but x is still x. It's measured that way. So the cosine of C is going to be defined not by the edges of the triangle, but by the coordinates of this point, which are the adjacent is x over the hypotenuse b. So cosine of C is x divided by b. And so if I multiply b to both sides, I can solve for x. X is equal to b cosine C. And then the sine of C, so it would be the opposite of the hypotenuse. It would be y over b, and so we multiply b on both sides. Y now, if we multiply the b over, is equal to b sine C. Okay, so A, this point up here, has the coordinates x comma y, has the coordinates b cosine C, comma b sine C. Now, using the distance formula, we can find C squared. And so the distance formula is, remember, if I subtract the x coordinates, I'm looking at these 2 points, x, y, and a comma 0. The distance formula would be the difference of the x coordinates. So the difference of the x coordinates is b cosine C minus a squared plus the difference of the two y coordinates, so that's b sine C minus 0 squared. And then usually if we're actually computing distance, we would square root both sides, but since we have C squared, the square root's not going to be there. Now this can be simplified, so let's simplify this equation right here. So if I write this twice or multiply it all the way out, I'm going to have b squared cosine squared C minus, I'm going to have an AB cosine C and another negative AB cosine C, so I'll have negative 2 AB cosine C, then we'll have an A squared. And then this last term we'll have, since I just have minus 0, I'll have B squared sine squared C. Okay. Now, we can rearrange this just a little bit. First of all, I have the B squared cosine C piece. So I'm going to write the a squared first, but if I simplify that, I've got our a squared plus that b squared can factor out of the sine squared c plus cosine squared c from these two pieces, right? b squared cosine squared c and b squared sine squared c. I can factor the b squared out of those two pieces, and we'll have that minus 2ab cosine c at the bottom over here. And then I know by one of the Pythagorean identities that the sum of sine squared c plus cosine squared c is 1. So this is going to turn into a squared plus b squared minus 2ab cosine c. And this is what c squared is equal to. Right? And so we have a formula for how to find that C side knowing just A and B and the cosine of an angle that's between them. So I don't need a pair where I have law of sines. Remember, I needed to have a pair of an angle and a side that matched. Here I have an angle that does not match one of the sides, and I can still use that angle and the two sides I know to find the third side, even though they don't form a pair of a opposite side and angle. Okay. Now, depending on how we rearrange this angle and drop hypotenuses down to make other right triangles, we can do this in any form. So the one that we found was the bottom one, c squared equals a squared plus b squared minus 2ab cosine c. It can be done in any form. What we're noticing in these is that the side that you're finding is across from the angle. So if you are using angle A, you're finding side little a. If you're using angle B, you're finding side little b. And the other sides, since order doesn't really matter, are just the other ones. So if I'm looking for B, then I have a squared c squared, and then I have 2ac. Okay, and then again, the one we found, which I knew angle C, and I could solve for side C. Okay. Now notice the law of cosines, it can be used in any triangle. What would happen in the special case where C is a right triangle? If C is a right angle, then the cosine of the right angle, 90 degrees, okay, so 90-degree angle, the cosine up here is the x-coordinate, that's the ordered pair 0, 1. The cosine of 90 is 0. So if it is a right triangle, we'd have c squared equals a squared plus b squared minus 0. And so if it is a right triangle, we're right back at the Pythagorean theorem. Oops, I can't see that. I just wrote Pythagorean theorem underneath that, but there we go. We're back at the Pythagorean theorem. And so this is that helps verify the law of cosines for us. It works in any triangle. Even if the triangle is right, it's still going to work because the last part just turns to 0 if your angle that you're referring to is the 90. That's interesting. All right, so let's take a look at the next page. We're going to solve some triangles here. In this first case, let me draw what this triangle might look like. I have a B angle that's 133 degrees. I'm going to draw an angle that's bigger than 90. Okay, so first I'm going to label this one as B, and it's 133 degrees. And I don't know little b, so I'll have to find that. I do know A and C, so let's say this one is A, which is 12. This one is C, which is 15. So across from side A is angle A, across from side C is angle C. Okay, and so I need to find all of the other things. Now, with only one angle, I cannot find another angle first. I'm going to have to go for this side using the law of cosines. I can't do law of sines because I don't have a pair to work with where I know both values in any of the pairs. I don't have a pair for C, a pair for A, or a pair for B, so law of sines won't work, but law of cosines will. Okay, so let's get our law of cosines started. Okay, so we're looking for side B, so we know that B squared is going to be A squared, so 12 squared, plus C squared, 15 squared, minus 2 times A times C, so 2 times 12 times 15, times the cosine of angle B, which is 133 degrees. Now, all of this is just a number, so if I have my calculator or Desmos in degree mode, I can just type this in. Got a calculator handy. I'm just going to make sure that it's in degree mode. Yes, it's in degree mode. So I can just type all that in. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 133 in degree mode. I just use the calculator because Desmos is in writing mode by default, and I didn't thought it would be faster to do it this way. It doesn't matter. You can type it in as well. So B squared is equal to 614.5, and then B would be plus or minus the square root of that. Oops, turned it off. Plus or minus the square root of that value. So plus or minus 24.7895. All right. Now, the triangle length right here, we have to decide if we want that to be allowed to be positive or negative. But because we don't have a quadrant definition of these, we're assuming that we're solving triangles right now with positive lengths, especially in this setup right here with these two positive sides, and that being the diagonal between them, I'm not thinking about that as being negative. We're going to select that to be the positive distance side right there. So that's going to give us one b value. So we have 24.7895 for a b value. We'll write that over here. 24.7895, I meant to say. All right. Now, I still have a bit of work to do to solve the rest of this triangle, but what this gives me is a pair. I still can't find one of the other angles by subtraction, but since I have this pair of values for b and b, I can use the law of sines now. So we'll start the law of sines. If we go back and label what we did first, this was our law of cosines. To solve a law of cosines problem, we often need to use the law of cosines and then the law of sines. We're not going to be able to use just the law of cosines independently. And so I can use the law of cosines with the ratio of the b's to find either a or c. Doesn't matter which one. Let's just go for a. Since it's the a value, the angle that I want, I'll put those on top. So we'll have the sine of a over side A, which is 12, equals sine of B, and B was 133, so sine of 133 degrees over side B, which is our 24.7895. And then if I multiply both sides by 12, we'll get the sine A by itself. All right, so then just again grab my calculator since I have it handy. Decimals would work just fine for this as well. They're just making a calculation here. So the sine of 133 divided by, I might be able to go up and hit enter on that number, perfect, and then times 12 gives us a sine A value of 0.354. So the sine of A is 0.354. And so that's our ratio, our trigonometric ratio. And so we can use the arc sine of that to find A. So A would be arc sine of this value. And so that gives me an angle of 20.7340. So 734 sounds sufficient there. Yeah, I wouldn't even round up to a 1. So it'd stay a 0 for the fourth place. Degrees. The other option, remember when we do law of sines, there are two options that had a sine ratio that was positive, because sine is positive in both quadrants 1 and 3. So one of them is our 20 degree and one of them is just shy of 20 degrees from 180. So if I take 180 and subtract 20, that gives me my other possibility that A could have been 159.266 degrees. Okay, so if I was just using law of cosines, I meant to say, with no other knowledge, I would definitely get those two choices for A. However, with already having a 133 degree angle in the triangle, 159 degrees is too large to fit inside the same triangle. So we're going to throw that one away as being too large. Together, those two angles are going to add up to more than 180, so that's not going to work. Okay, so that one we can throw out as not going to work. And then we have another choice to find angle C. We could do another law of sines, or since I have two angles now, it makes the most sense probably to just subtract from 180 to find it. So for our last piece that we need, angle C, we'll just find it with 180 minus the 133 minus the 20.734 degrees. And so just a quick calculation and subtraction to subtract those values, and I get 26.266. I have to, if I even round it 3 places, it's going to be just 60 right there, degrees. Okay, and that gives us all of the pieces that we needed to solve for. We needed to solve for little b, we needed to solve for angle A, and we needed to solve for angle C.